A great day to one and all. I am Mr. Kim J.C. Ensho, a faculty member of Iloilo National High School, SPSTE, and I will be discussing with you finding terms of arithmetic sequences. So for this video, for this lesson, I will be discussing various ways or simple ways to find the values of terms of arithmetic sequences. If we could still recall, when we speak about arithmetic sequence, let's abbreviate it as AS for now. It is a sequence in which the difference between any two consecutive terms is constant. This constant is called common difference, denoted by the small letter d. For example, if you have the arithmetic sequence with these four terms, a sub 1, a sub 2, a sub 3, a sub 4, then if you subtract the second by the first, the third by the second, the fourth by the third, then all of these differences is constant. That is your common difference or your D. I hope we could still recall this. For example, let's consider this question. Consider the arithmetic sequence 10, 17, 24, 31, 38, and so on. What is the value of the seventh term? Before we get the value of the seventh term, I stated here it's arithmetic, but if you wish, you could actually verify that using the definition I gave earlier or the condition I gave earlier. 17 minus 10, you have 7. 24 minus 17, you also have 7. 31 minus 24, that's 7. 38 minus 31, it's 7. So in this sequence, if you have a certain term and subtract it by its immediately preceding term, then you get a constant value, which is 7. So this sequence has a common difference of 7, and it is indeed arithmetic. So what is the seventh value of this sequence? In the last videos I gave you last time, we talked about recursive form of an arithmetic sequence. Before we discuss the answer to that question, let me give you an example. Let's say we have this simple arithmetic sequence, 1, 3, 5, 7, and so on, with the first term or a sub 1 equals 1, and a common difference of 3 minus 1, which is 2. How come? 3 minus 1, 2. 5 minus 3, 2. 7 minus 5, it's also 2. So your common difference here is 2. Note as well that since your sequence is increasing, it's increasing from left to right, that is why your common difference has to be positive. If you see your third term, I mean your second term, which is 3, from the first term, you added 2, right? That's why I expressed 3 as 1 plus 2. But going back here, what is 1? 1 is your first term. That is why I substituted 1 into a sub 1. What is 2 here? It's your common difference or D. That's why I substituted 2 with D. That's why 1 plus 2 is equal to a sub 1 plus D. So in this case, we are doing kind of the reverse. Given the specific values, we are going to express them to their variable form. If you have the third term, which is 5, from the second term, which is 3, its immediately preceding term, which is 3, you added 2. That's why I expressed 5 as 3 plus 2. But 3 is your second term, right? That's why I substituted this 3 with a sub 2, and this 2 is still your D. That's why a sub 3 is a sub 2 plus d. How about for the fourth term, which is 7? For the fourth term, you could actually see that immediately before 7, it's 5. And you added 2 to it. That's why I express 7 as 5 plus 2. But what is 5? It is a sub 3 plus your 2, which is your common difference. That is why a sub 4, or the fourth term, is equal to a sub 3 plus d. And in general, if you could notice, if it's a sub 2, that's a sub 1 plus d. If it's a sub 3, that's a sub 2 plus d. If it's a sub 4, it's a sub 3 plus d. So how about for a sub n? It will be a sub n equals a sub n minus 1 plus d. How did I arrive to this? Because if it's 2 here, it's 1. If it's 3, 2. If it's 4, we have 3. And if it's n, then this one should be 1 less than the n here. That's why a sub n minus 1. That is why an arithmetic sequence is defined by the recursive relation a sub n is equal to a sub n minus 1 plus d. That is, to get this next term, to get a certain term, all you have to do is add the immediately preceding term with the common difference. So that's your recursive relation or recursive form. That is, when we speak about recursive relation again, it's to get the value of the succeeding term, you need the value of the preceding term. So if we go back to our question earlier, consider this arithmetic sequence 10, 17, 24, 31, 38, and so on. And if we find a sub 7, we have to remember that if we could see here that the common difference is 7. I believe you would agree on this, as discussed earlier. And using the recursive relation, we have 1, 2, 3, 4, 5. We have the fifth term. Before we get the seventh term, we still need the sixth term. That's why if I let n be equal to 6 and substitute to the recursive form earlier, a sub 6 will be a sub 5 plus d. But what is a sub 5? It is 38. The fifth term is 38. And our d is 7. So we have 38 plus 7, which is 45 as the sixth term. And how about the seventh term? So since you have the sixth term, you can now get the seventh term. So substituting n by 7 to the recursive relation formula earlier, we have a sub 7 equals a sub 6 plus d, but a sub 6 is 45 plus d, or your common difference, which is 7. That's why 45 plus 7 equals 52. So 52 is indeed the seventh term of this sequence. And if you answered 52, great job. All right. But we know that the recursive form is important as well. But the weakness of the recursive form is that sometimes it would take you a long time, especially if the term that you are looking for has a large subscript. For example, if you're given a sub 1 and you're looking for a sub 100, so it will take you a lot of steps to do that. That is why even though the recursive form is important, for our class, we will not use it as often, depending on the situation, and we will resolve or use the explicit form of an arithmetic sequence more often. So for the explicit form of an arithmetic sequence, all we have to do is find a general formula and substitute the value of n, and after which we get, after evaluating, then we get immediately the value of that term. So let's go back again to our example earlier. To let's say we have 1, 3, 5, and 7. It's known that our first term here is 1 and our common difference is 2, right? For the explicit form of an arithmetic sequence, we will rely on the value of our first term and will count how many times we added the common difference to reach the indicated term. For example, if I have a sub 2, which is 3 here, from the first term 1, how many times did we add 2? We just added 2 once. That's why I express 3 as 1 plus 1 times 2. That's why you could see here 3. From the first term, I added 2 once. That's why I express it as 1. 3 could be expressed as 1 plus 1 times 2. But why 1 times 2? Because I added the common difference, which is 2, 1 time. But we know that 1 here is a sub 1. That's why I substituted 1 with a sub 1 in this 2 as d. That is why 3, your a sub 2, is equal to the first term plus 1d, or simply a sub 1 plus d. If you have the third term, which is 5, how many times did we add 2? We have 1, 2. So you added the common difference twice from number 1, from the first term, which is 1. That's why I expressed 5 as 1 plus 2 times 2. 1 was added with the common difference 2 twice. But substituting 1 again, or replacing 1 with a sub 1 and 2 with d, so a sub 3 is equal to a sub 1 plus 2d. For the fourth term, which is 7, how many times did you add 2? We have 1, 2, 3. So you added 2 3 times. That's why a sub 4, which is 7, is expressed as the first term 1 plus 3 times 2, because we added 2 3 times. Replacing again 1 with a sub 1 and 2 with d, that's why I expressed a sub 4 as a sub 1 plus 3d. So observe, if you have a sub 2, that's a sub 1 plus 1d, or a sub 1 plus d. If it's a sub 3, a sub 1 plus 2d. If it's a sub 4, it's a sub 1 plus 3d. So if you could notice, we always have a sub 1s. And the number that's multiplied to d here is 1 less than the subscript here. So if it's 4, if it's 2, 1. If it's 3, 2. If it's 4, 3. And how about for a sub n? So if we are going to generalize this for a sub n, then we will have a sub n is equal to a sub 1 plus the subscript minus 1. So we have here n minus 1 multiplied with d. That's why, ladies and gentlemen, this is now the explicit formula of in finding a certain term of an arithmetic sequence. That is, a sub n is equal to a sub 1 plus n minus 1 times d, where a sub n here is the nth term, a sub 1 is the first term, n is the number of terms, and d is the common difference. So please take note of this formula because we will be using it almost all throughout our topic in arithmetic sequence. All right? So let's apply this formula now to the very first question that was thrown earlier. So if we consider the arithmetic sequence 10, 17, 24, 31, 38, and so on, find a sub 7. So we see that your first term here, or a sub 1, is 10. Since we are looking for a sub 7, and your subscript here is 7, then that also serves as your n. And if your n is 7, and we could see as well that your d, or common difference, is 7, and we are looking for a sub 7, and by substitution to a sub n equals a sub 1 plus n minus 1 times d, we will replace all n's by 7, and by substitution of the rest, we have a sub 7 equals 10 plus the quantity, your n, it's 7 minus 1 times 7. 7 minus 1 simplifies to 6. So a sub 7 is equal to 10 plus 6 times 7. By the GEMDAS rule, 6 times 7 first, which is 42. And a sub 7 is 10 plus 42, or 52. So if you could see from here, whether we used the recursive or the explicit form, we still got the correct answer of the 7th term, the correct value of the 7th term, which is 52. I hope you got it. All right, I hope you got it. And let's have some more exercises. Okay, let's have this one. Consider the arithmetic sequence 5, 2, -1, -4, and so on. Find a sub 11 or the 11th term. Feel free to pause the video, work on it first, and see if you will get the correct answer the same as I did. Okay, let's discuss the solution. For this one, you could see that the first term, or the first number that appears in the sequence, is 5. So a sub 1 is 5. You could also see that the sequence is decreasing, right? So I believe you would agree with me that your n is 11 because we're looking for a sub 11. Your common difference is -3 because 2 minus 5, it's -3. -1 minus 2, it's -3. -4 minus -1 will become -4 plus 1, which is -3 as well. And we're looking for a sub 11. So since these three were given, so we can now solve for the 11th term. So using the explicit form, a sub n is equal to a sub 1 plus n minus 1 times d, replacing all n's with 11 and substituting the rest. We have a sub 11 equals 5 plus the quantity 11 minus 1 times -3. 11 minus 1 is 10, so we have a sub 11 equals 5 plus 10 times -3. We could multiply the 10 and -3 into -30, and that the sum of 5 and -30 is -25. Hence, the 11th term of this sequence is -25. Some of us might not be convinced, like, how sure are you that it's really the 11th term? So in my case, I listed some of them. So continuing the pattern, we have 5, 2, -1, -4. We have -7, -10, -13. I have listed this 7 so far. I need the 11 terms, so I need to list 4 more. After -13, we have -16, -19, -22, and -25. So you could see, either using the explicit form of an arithmetic sequence or by listing, you still arrive to the same correct answer. The answers here are consistent, so this is actually telling us that we have the correct answer for our 11th term. Okay, I hope you got it. Let's proceed with exercises. For this part, I will be giving you some questions or some problems. You and you will try your best to solve them. Feel free to pause the video and solve on your own. Given the arithmetic sequence with various given or givens, find the indicated term. For letter A, the first term A sub 1 is 5, n equals 15, d equals -8. We're looking for A sub 15. So since all of these variables are given, so we can just perform direct substitution and simplify. By using this explicit formula again, we have A sub 15 is equal to 5 plus 15 minus 1 times -8. 15 minus 1 is 14, so we have 14 times -8 here, which is -112. So the A sub 15 is 5 minus 112, or that gives you -107. So if you're going to list or follow the pattern of this arithmetic sequence, the 15th number that you will list is -107. I hope you got it. Okay, letter B. How about if you have 8, 10, 12, 14, and so on? We are looking for the 9th term. So for the solution of this, you could see that the first term is 8 because that's the very first number. Your n is 9 because this is the subscript of your A. So we are looking for the 9th term. So n must be 9. And you see that the common difference here is 2. So applying in this explicit form, we have A sub 9 equals 8 plus the quantity 9 minus 1 times 2. 9 minus 1 is simplified to 8, and the rest were just copied. You have to multiply first before adding. 8 times 2 is 16. So you have A sub 9 equals 8 plus 16, and that gives you A sub 9, which is 24. You may list on your own, and I believe you will verify. You can check that you will indeed get 24 as the 9th term. Letter C. The first two terms are 4.5 and 6. Find A sub 21. So in this case, what does this mean if I say the first two terms are 4.5 and 6? If you encountered something like this, be reminded that it is understood that the first number mentioned is the first term, or A sub 1, and the second number mentioned after the word end is your second term, or A sub 2. So it's understood here that your A sub 1 is 4.5. Since you're looking for A sub 21, the subscript here is 21, so that will be your n. And remember, basing on the one I presented earlier, to get the common difference, you actually have to subtract a term by its immediately preceding term. That is why the common difference is in fact the second term minus the first term, which is 6 minus 4.5, or 1.5. All right? So since we have now the values we need, we can now substitute it to the explicit form, which is A sub n equals A sub 1 plus the quantity n minus 1 times d. And that gives us A sub 21 equals 4.5 plus 21 minus 1 times 1.5. If you wish to have fractions like 3/2, go ahead. It's your choice. You will still get the same correct answer. 21 minus 1 simplifies to 10, to 20 rather, sorry. Then the rest were copied. 20 times 1.5 is 30. That's why A sub 21 is equal to 4.5 plus 30, which is 34.5. I hope you got it. Let's move on to the next one, letter D. Suppose I have here 13 tenths, 1, 7 tenths, and so on. What is the 12th term or a sub 12? So for this one, we could see that the first term is 13 over 10. Your subscript here is 12, so n should be 12. And if you subtract 1 minus 13 tenths, that's negative 3 tenths. 7 tenths minus 1, that's also negative 3 tenths. You could verify that with your calculator if you wish, or you may solve on your own. We have the needed info. So by substituting, we have a sub 12 equals 13 over 10 plus 12 minus 1 times the quantity negative 3 tenths times negative 3 tenths. 12 minus 1 simplifies to 11. And the rest were copied. 11 times negative 13 over 10. I mean negative 3, 11 times negative 3 tenths. So 11 times negative 3 tenths is negative 33 over 10. That's why a sub 12 is equal to 13 over 10 minus 33 over 10. So we have similar fractions here. So all we have to do is subtract their denominators and copy the common, subtract their numerators and copy their common denominator. 13 minus 33, it's negative 20 over 10, which simplifies to negative 2. So the 12th term is negative 2. I hope you got it as well. And let's have another one, letter E. Supposing the first term is negative 10 and the fifth term is 2. What do you think is a sub 14? So unlike earlier, you're given the first term and the second term earlier. So you just have to subtract them, the second by the first, you get D. But in this case, you are given a sub 1, which is negative 10. You are given your n, which is 14. But you don't know yet your D, or common difference. So for this case, we need to solve for D first. And still, the formula a sub n equals a sub 1 plus n minus 1 times D will still be very useful for this case. Now, remember we are given a sub 5 equals 2. So in a sub 5 equals 2, you see that the subscript of a is 5. So this is n, which is 5. So we will replace all n's here with 5. And you will have a sub 5 equals a sub 1 plus 5 minus 1 times D. 5 minus 1 simplifies to 4. That's why a sub 5 is equal to a sub 1 plus 4D. And what should we do next? You could see that we have the fifth term, which is 2. So we will substitute a sub 5 with 2. We also have a sub 1, which is negative 10. So we will replace a sub 1 with negative 10. By this, we can solve for D. With such, we arrive to 2 equals negative 10 plus 4D. We will add both sides by 10 to isolate the 4D. So 2 plus 10 will be 12. And the right side will be 4D. So 12 equals 4D, dividing both sides by 4 gives you the value of the common difference, which is 3. So since we have now your D, or common difference, which is 3, we may now solve for the value of the 14th term. Using again the explicit formula, Our n will be substituted by 14. Our a sub 1 will be negative 10. And our n will be 14. Our d will be 3. We have a sub 14 equals negative 10 plus 14 minus 1 times 3. 14 minus 1 simplifies to 13. The rest were just copied. So a sub 14 equals negative 10 plus 13 times 3. 13 times 3 is 39. And negative 10 plus 39 is 29. Hence, if you are going to write the terms of the sequence and follow the conditions stated earlier, I'm sure that the 14th number that will be on your list will be 29. And if you have questions or clarifications, please feel free to chat me, or you may write your comments in the description box below. So if you wish, feel free to subscribe and like this video if you want to. With that, thank you very much and a great day to one and all. God bless everyone.